We may have just found the strongest evidence for alien life, and it's on a world 124 light years away. On April 17th, 2025, data from the James Webb Space Telescope revealed something that sent shockwaves through the scientific community. A distant exoplanet designated K218b showed atmospheric signatures with a staggering 99.7% probability of indicating biological activity. This isn't about little green men, but something potentially more profound: a living ocean world. The chemical detected, dimethyl sulfide, is a compound that on our planet is almost exclusively produced by living organisms. And the concentration in this alien atmosphere is 1,000 times greater than what we find here on Earth. We are not just looking for life, but for an entire living world. What does this mean for our place in the cosmos? The story of K218b began back in 2015. NASA's Kepler telescope, during its extended K2 mission, identified over 1,000 new worlds. One, in particular, stood out. It was about 2.5 times the size of Earth and nearly 9 times more massive. Scientists named it K218b. In 2017, the Spitzer Space Telescope confirmed the planet resides in the habitable zone of its red dwarf star, the region where temperatures could allow for liquid water. Around the same time, observations from the HARP spectrograph in Chile suggested the planet's density was consistent with a world possessing a vast ocean. The pieces were falling into place. Then, in 2019, the Hubble Space Telescope made a critical discovery: water vapor in the atmosphere of K218b. The idea of a life-supporting ocean was becoming less like fantasy and more like a tangible possibility. But the real breakthrough came in 2023. The powerful James Webb Space Telescope turned its gaze toward this distant world, and its sensors picked up a signal that left researchers in disbelief. They found traces of dimethyl sulfide, or DMS. On our planet, this gas is primarily generated by phytoplankton and other marine microbes. Could this be the first true sign of life beyond our solar system? Yet, the scientific process demands rigor. There was a chance it was an error, a ghost in the machine. The initial reading came from just one instrument, and distinguishing DMS from other gases like methane is notoriously difficult at that range. To eliminate doubt, NASA scheduled a follow-up observation using a different instrument on the Webb telescope, one that operates in the mid-infrared spectrum. On April 17, 2025, the new data arrived. The results were undeniable. Dimethyl sulfide was confirmed. Not only was it present, but its potential concentration was colossal, 1,000-fold higher than Earth's levels. This gas is incredibly unstable. In an atmosphere, it only lasts for a few days before being broken down by sunlight. This means it cannot simply accumulate over time. It must be constantly and massively replenished. On our world, that replenishment is a product of life. A gas that vanishes demands a source that is constantly creating. So, what could be producing it on such an unimaginable scale on K218b? Detecting a fleeting gas from 124 light years away is a monumental achievement. The Webb telescope accomplished this by observing the starlight that filters through the planet's atmosphere during transit. The atmosphere acts like a cosmic filter, absorbing specific colors of light that act as fingerprints for the gases within. By decoding these subtle changes in the star's spectrum, astronomers can reconstruct the atmospheric composition from an impossible distance. But to understand the potential for life, we must look at the planet's environment. K218b orbits a cool, dim red dwarf star. Its orbit is much closer than Mercury's is to our Sun, but because the star is so much cooler, the planet receives a similar amount of energy as Earth does. This delicate balance places it squarely in the habitable zone. Scientists theorize it could be a Hycean world. a planet entirely covered by a deep global ocean beneath a thick, hydrogen-rich atmosphere. Further supporting this, a lack of atmospheric ammonia was detected, which would be expected if it were dissolving into a vast ocean. However, significant doubts remain. If this is a water world, the conditions at the bottom of a deep ocean could be extreme, with crushing pressures and scorching temperatures from the planet's interior, creating a hellish environment rather than a nurturing one. There is also an ongoing debate about the planet's very nature. Some scientists, like Dr. Nicholas Vaughan of NASA, suggest K218b might be a mini-Neptune, a small gas giant with no solid surface, which would extinguish hopes for life as we know it. But the lead researcher of the Webb study, Professor Niku Madhusudan from the University of Cambridge, remains far more optimistic. His team is convinced the evidence points toward an ocean world that could be brimming with biological activity. He believes that within the next 1 to 2 years, they will know with absolute certainty whether this gas is present and whether its origin is biological. The current confidence level for potential biosignatures sits at 99.7%, which in scientific terms is a 3 sigma level of certainty. This is the highest confidence ever achieved in the search for life beyond Earth. For comparison, initial observations only had a 68% confidence level. But to claim a definitive discovery, the scientific community requires a 5 sigma level of certainty, a 99.99994% confidence, meaning there's only a 1 in a million chance of error. This is the same standard used to confirm the Higgs boson. The team at Cambridge is proceeding with caution. They know the world is watching. The next steps are clear. Confirm the presence of DMS at the 5 sigma level, and then prove its origin is biological. If both are true, we will have witnessed one of the most profound discoveries in human history. The first confirmed signs of extraterrestrial life. And the most staggering part? This potential alien biosphere is, cosmically speaking, right next door. At 124 light years away, the distance is undeniably vast, about 730 trillion miles. Human interstellar travel remains a dream, but on the scale of our galaxy, this world is a close neighbor. Its light, carrying these tantalizing clues, has been traveling for just 124 years to reach us. If you found this journey to a potential new living world as fascinating as we did, please show your support by liking this video and subscribing to Winds of Thought for more deep dives into the universe's greatest mysteries. What do you think is living in those distant oceans? Let us know in the comments. What if life exists on a world just 124 light years away, forcing us to rethink our entire cosmic perspective? In the immense span of the universe, spanning over 93 billion light years, a planet like this is merely a pinprick. Finding life there would be akin to discovering a hidden treasure in your own backyard after searching the entire globe. This would imply that life could be commonplace throughout the cosmos, fundamentally altering our comprehension of biology's prevalence. For now, this remains a compelling hypothesis under intense investigation. Despite scientific caution, one truth emerges: humanity has never been nearer to resolving the ultimate query of whether we are alone. What might life actually look like on this enigmatic world? As researchers pursue definitive proof, we can venture into a speculative future, picturing biological forms on this distant planet. Logically, we start with the microscopic. On Earth, life commenced with tiny organisms, and on K218b, it likely followed a similar path. Primary inhabitants could be microbes enduring a hydrogen-rich atmosphere, high pressures, and elevated temperatures. These might echo Earth's extremophiles, organisms thriving in deep ocean hydrothermal vents where heat surpasses 100 degrees Celsius. Such life wouldn't need sunlight. drawing energy directly from chemical processes like hydrogen sulfide oxidation. On K218b, similar reactions could be plentiful due to the hydrogen atmosphere and potential volcanic actions. If life there advanced beyond microbes, a fascinating inquiry surfaces. How might more complex beings appear under these circumstances? A profound ocean under a dense atmosphere would be nearly pitch black, so vision might not be the main sense. As on Earth's sea floors, creatures could navigate using vibrations, thermal signals, magnetic fields, or chemical cues. Some might evolve bioluminescence, generating their own light similar to fireflies or deep-sea anglerfish. But one particularly captivating aspect is the possible scale of these organisms. In a hydrogen atmosphere, where density is lower than Earth's, life could gain growth benefits. Hydrogen's lightness means buoyancy forces would be stronger, potentially fostering much larger beings than on our planet. Imagine sluggish, massive entities adapted to high pressure and dense waters. Perhaps colossal jellyfish or shapeless forms gliding through warm oceanic depths, or even floating in the atmosphere itself. Additionally, coping with enormous pressure would be a critical trait for these life forms. K218b's ocean might be vastly deeper than Earth's, and if diverse life exists, some species could thrive at depths of 10 to 15 miles, with pressures reaching 1,600 to 2,400 atmospheres, dwarfing the Mariana Trench's extremes. To survive such environments, animals on K218b might have bodies built to resist immense pressure. One idea is a robust yet flexible exterior shell shielding internal organs. These creatures could possess dense, cartilage-like or bony structures made of durable biopolymers, far stronger than those in Earth's life. Envision beings with external skeletons coated in a unique substance that not only handles high pressure but also lessens its effect on inner tissues. These frameworks might recall the exoskeletons of crabs, but be much denser and more deformation resistant. Their bodies could be adorned with tough biological scales or armor that is both pliable and sturdy. Naturally, this is all conjecture. We're unaware of the metabolic reactions driving any potential life there, or if it exists at all. We don't know which molecules serve DNA's role on Earth, but if the observed dimethyl sulfide is biologically produced, it signifies that life isn't just plausible. It's already evolved. We may be witnessing not just life, but an entire biosphere in motion. And perhaps, right now in the warm abysses of that far-off ocean, entities are slowly shifting, for whom Earth is as alien and inaccessible as their world is to us. While K218b is now the top contender for alien life, it's certainly not the sole candidate. Consider another captivating planet, Teegardens b. It's a mere 12.5 light-years distant, which in cosmic terms is practically our neighbor. Scientists gauge around a 60% likelihood of Earth-like conditions there. Moderate temperatures from 0 to 50 degrees Celsius, liquid water, and a fairly stable climate. All of these could potentially exist on Teegardens b, however. A critical caveat is that such conditions present to probably only occur in a slim transitional area between day and night. The planet is most likely tidally locked, always presenting the same face to its star. This means one hemisphere is in endless daylight while the other is in perpetual darkness. Consequently, temperatures swing from blistering heat to freezing cold. Precisely at the border between these two extremes lies the twilight zone, where a temperate climate might persist. Liquid water could exist here, and thus life too, possibly even complex multicellular organisms. Another compelling planet where life might thrive is Kepler 1649c. Discovered in 2020, it resides 301 light-years from Earth in the constellation Cygnus. Despite the distance, it boasts features that intrigue scientists. This world orbits a small, faint red dwarf roughly 5 times less massive than our Sun and 4 times smaller. Thus, the planet gets about 25% of the light and heat Earth receives from the Sun. The planet itself is slightly bigger than Earth, with about 6% greater radius and 20% more mass.
so gravity would feel quite similar, not too strong or weak. However, like T-Garden B, Kepler 1649c probably faces a major habitability hurdle. It's likely tidally locked too. This could create severe conditions with one side overly hot and the other frigid. Yet, as with T-Garden B, in the twilight belt between the sides, a stable climate with Earth-like temperatures and liquid water might exist. In this slender band between light and dark, primitive life could potentially find sanctuary. TOI 700D is another promising habitability candidate. Located in the constellation Dorado about 101 light-years away and found in 2020, it's the third and outermost planet in the TOI 700 system and possibly the most intriguing. Unlike T-Garden B and Kepler 1649c, which are probably tidally locked and always show one side to their star, TOI 700D may not be locked yet. Thanks to this, TOI 700D could still have day-night cycles, leading to a more stable and life-friendly environment. The planet receives roughly 86% of the light Earth gets from the sun. Slightly less, but sufficient. Its calculated surface temperature is around -4 degrees Celsius, which is chilly, but not extreme. And with even a mild greenhouse effect, conditions could become much warmer. In size, TOI 700D is just a bit larger than Earth, with slightly greater mass and radius, meaning gravity would be a touch stronger but still agreeable for potential life. Another plus is that the star TOI 700 is relatively calm. It doesn't emit powerful flares or storms that could strip the planet's atmosphere, a rarity among often volatile red dwarfs. A serene star boosts the odds of an enduring atmosphere, oceans, and maybe even life. Of course, we can't yet confirm what's on TOI 700D's surface, but mounting evidence puts it firmly on the list of most promising exoplanets we know. However, not all interesting planets mirror Earth. Some appear lifted from science fiction, and J1407b is among the oddest worlds scientists have uncovered. J1407b is one of the most bizarre planets ever found. Situated about 434 light-years from Earth, it's like Saturn on steroids. Astronomers find it tricky to pin down its mass exactly, but estimates range from 10 to 40 Jupiter masses. J1407b is a gigantic planet, far larger than the biggest planet in our solar system. Some worlds defy imagination, reminding us of nature's boundless creativity. The astronomical community was stunned by the discovery of a planet with a ring system of unimaginable scale. This distant world features 30 distinct rings, each spanning tens of millions of kilometers in diameter. Rough estimates suggest the entire system measures 120 million kilometers across, making it 200 times larger than Saturn's rings. If Saturn had rings this vast, they would dominate our night sky, outshining all but the moon. However, this magnificent view would be temporary, as the rings would gradually thin and form new moons around the planet. But this is only a glimpse into the universe's catalog of wonders. What other bizarre worlds await discovery? How can a planet be hotter than its own star? Or how can one be larger than the star it orbits? Is there truly a planet with the density of a marshmallow? We've gathered the most mind-blowing exoplanets known to science. First, meet GJ504b, located 57 light-years from Earth. This Jupiter-sized planet has 4 times Jupiter's mass, but glows with a peculiar pink color. What causes this pink hue? The system is young, only 160 million years old. and the planet is still cooling from its formation, emitting a faint magenta glow as it loses heat. The universe isn't just about color, it also boasts water-rich worlds. Enter GJ1 214 b, a Neptune-like exoplanet with a mass over 8 Earths and a radius 0.24 times Jupiter's. While its water content seems promising, this isn't. It lacks a solid surface, and its atmosphere is vastly different. Under extreme pressure and heat, water exists in a plasma state, behaving unlike anything on Earth. Temperatures hit 280 degrees Celsius, but water here is in a supercritical fluid phase, sharing properties of liquids and gases. On some worlds, water becomes an alien substance. Next, journey to the constellation Cygnus, where Kepler 70b resides 650 light-years away. With a mass of 0.44 Earths and a radius 0.75 times Earth, it's one of the hottest exoplanets known. Its star, Kepler 70, was once like our Sun, and Kepler 70b was a Jupiter-sized gas giant. About 18.5 million years ago, the star became a red giant engulfing the planet. Now, only a hot iron core remains, and scientists believe it's still evaporating, shrinking further. How hot is it? Orbiting 65 times closer to its star than Mercury to the Sun, temperatures reach 6,650 degrees Celsius, hotter than the Sun's surface at 5,500 degrees Celsius. Another scorching world is WASP-76b, 640 light-years distant. Discovered in 2016, it's nearly Jupiter's mass and tidally locked, with one side always facing its star. The day side reaches 2,350 degrees Celsius, vaporizing metals like iron. Radiation here is thousands of times stronger than on Earth. The night side is nearly twice as cold, creating fierce winds that carry iron vapor to the cool side, where it condenses into molten iron rain. Imagine a world with liquid metal precipitation. But the strangest may be PSRJ 17191438b. What makes it so impressive? This exoplanet is 3,000 times larger than its host neutron star. Incredibly, it wasn't always a planet. It began as a star. Let's explore its story. The planet orbits a neutron star just 20 kilometers across, so dense that one teaspoon weighs billions of tons on Earth. This star is a millisecond pulsar, spinning 10,000 times per minute and emitting radiation beams. It's not alone. It has a companion planet about 40% Jupiter's size. From ring giants to iron rain worlds, exoplanets display incredible diversity. If you enjoyed this cosmic tour, please like this video and subscribe to Lines of Thought for more universe explorations. Which of these planets fascinates you most? Share in the comments. What if I told you there's a planet made of diamond orbiting a dead star? PSRJ 17191438 B represents one of the universe's most extraordinary transformations. This alien world exceeds Jupiter in mass, yet maintains remarkable compactness. How can something so dense exist? The explanation lies in its dramatic history. This was once a star whose outer layers were stripped away by an immensely powerful neighboring pulsar. What remained was a carbon-rich remnant that crystallized into a diamond world approximately 5 times Earth's size, with a diameter around 60,000 kilometers. The entire system is so compact it can fit within our Sun's diameter. Space continues to surprise us with increasingly peculiar exoplanets. Take WASP-107b, a world so lightweight it defies conventional planet formation theories. While matching Jupiter in size, this peculiar planet contains only 30 Earth masses, compared to Jupiter's 300. Even more puzzling, its core measures just 4 times Earth's core, rather than the expected 10 times. This creates an incredibly low density, giving WASP107 be the consistency of cosmic cotton candy floating through the void. While most exoplanets seem inhospitable, Gliese 581d offers potential hope for future colonization. Located within 20 light years of Earth, this world has about 6 times Earth's mass and resides within its star's habitable zone, suggesting temperatures might permit liquid water. Though tidally locked, creating permanent day and night sides, abundant atmospheric carbon dioxide likely prevents the dark side from freezing completely. Where would humans settle? The ideal location would be the twilight zone along the day-night boundary. Some worlds challenge everything we know about planet formation. The cosmic scale becomes truly apparent with 2MASSJ2126. Initially classified as a lonely rogue planet, astronomers discovered it actually accompanied star TYC9 4869271. Surprisingly, both objects were known for years before their connection was recognized. They orbit at a staggering trillion kilometers apart, 7,000 times Earth's distance from the Sun. This colossal orbit means 1 year there equals approximately 900,000 Earth years. Now, let's consider moons around distant worlds. While Jupiter boasts 79 moons, detecting exomoons has proven incredibly challenging. Until now. Astronomers using the ALMA telescope in Chile have found the first clear evidence of a moon-forming disk surrounding exoplanet PDS-70c. This disk contains enough material to form 3 satellites, each moon-sized. For the first time, we're witnessing how moons form in real time, not just through simulations. Our final destination is KOI 5AB, remarkable not for its properties, but its celestial neighborhood. This Saturn-sized planet was initially overlooked due to its complex arrangement, but later observations revealed a triple star system. The planet orbits star A, which has a close companion, star B. They orbit each other every 30 years. A third star, star C, orbits both every 400 years. Imagine standing on this world. Instead of one sun, you'd see 2. One significantly larger than our sun, the other much dimmer yet still glowing 1,000 times brighter than our full moon. The universe's creativity knows no boundaries. From diamond worlds to triple sun systems, these discoveries continually expand our cosmic imagination. If you found this journey fascinating, please like this video and subscribe to my channel Galaxy Stream of Thought for more explorations of our incredible universe. Which of these exotic systems would you most want to visit?